Good afternoon, everyone. My name is Lynn Jenkins from ByteCubed. Thank you for taking the time to participate in today's workshop. This is the 10th in a series of workshops delivered in this webinar format. Next slide. Today's workshop topic focuses on test and evaluation. Next slide. In terms of audio, all participant microphones are muted for the duration of the webinar. Today's format is structured as follows: presentation, panel discussion, a brief Q&A, and a post-workshop feedback survey. At the end of this webinar, you'll be automatically redirected to a page where you will be asked to provide some feedback regarding today's workshop. It should take you less than 5 minutes to complete the survey. We will also send you the survey to the email you used to register. In terms of Q&A, we've received advanced questions, some of which will be addressed during today's presentation, and others that will receive a direct response during the Q&A session. We also encourage you to review previous workshop transcripts, recordings, and slides for other topics. This information can be found on our website. The web address is found on the last slide of this presentation. If you have questions during the presentation, please click on the blue question mark located at the top of the page. Please limit today's questions to the scope of this workshop's topics. We'll also send an audio recording within 2 days of workshop completion, as well as a transcript in 30 business days. Next slide. The objectives of today's workshop are to help you understand the importance of testing, test phases, key considerations, and lessons learned. Next slide. Today we are joined by presenters and panelists with vast test and evaluation and test measurement expertise. I'd like to remind all speakers to please state your name, organization, and role prior to your initial presentation slide, as well as during the panel discussions. Today's moderators are myself, Lynn Jenkins, and Phil Reeves. Our panelists are Steve Seiden from Acquired Data Solutions, Colin Bowers from Ramparts, and Chris Medding from AccuStrata. I'd like each presenter to give us a brief overview of your background and qualifications. I'd like to start with Steve Seiden.
Good afternoon. My name is Steve Seiden, and I'm the president of Acquired Data Solutions. We are a 21-year-old test and measurement and evaluation company. We are servicing both DoD and DHS and commercial customers as well. And we have experience in DT&E testing, developmental tests, and just getting things working like in a phase 1, and OT&E experience.
Thank you. And our next presenter I'd like to introduce is Colin Bowers.
Hi. I have over 30 years experience as a government employee with DoD, doing mission critical systems and infrastructure testing. In 2013, I started Ramparts. One of our focuses has been on metric-based cyber physical testing. The testing that we've done in the past has been both cyber security, functional, and safety testing.
Thank you. And our other presenter today is Chris Medding from AccuStrata.
Hi, I'm Christopher Medding from AccuStrata. We focus on custom optical metrology solutions. So we develop prototypes and novel combinations of optical monitoring with machine learning. And so we are very familiar with going out, getting the SBIRs, helping the government develop these novel technologies. And so that's what our focus is.
Okay, perfect. So now we're going to get started with our presentation, and I'm just going to actually transition right to Chris Medding to talk about our audience. Next slide.
So today we're going to focus on addressing mostly individuals who are interested in test and evaluation, who either are interested in SBIRs, STTRs, maybe you're entering in, you're thinking about supporting an idea that you have and looking for ways to support the development of that. Through an SBIR phase 1. Maybe you have the SBIR phase 1 and you're learning how to best capitalize on getting a phase 2 and that kind of thing, and what kind of testing and evaluation that you would want to do to help better your chances of getting a phase 2. And then the phase 2B, which is a follow-on to the phase 2. We're going to focus a lot, hopefully, on illustrating the differences between test and evaluation and SBIR tech development in general versus developing technologies that through traditional sort of commercial avenues. So that's going to be what we're focused on.
Great, Chris. Thanks for the introduction. I'd like to turn over to Steve to talk about DoD and their testing environment. Next slide, please.
This is Steve. For many of you who are going to focus on DoD SBIRs, it's important to know that these labs are there for you and they are there to assist you the best way they can. So it's really important that you understand the policies of these labs, and it's really important that you understand the processes. So one of them is the CRADA. CRADA is usually only set up for potentially a phase 3, but you want to get that in and done early, because if it's done early, then you are working with the lab, they're getting to know who you are, they're getting to know that you want an SBIR, they're getting to know that you are serious and you need integration time in their labs in order to be successful for your testing and your mission. And one of the most important things is that remember that these labs do not work on the same schedule as you do. So the more prep time you give them, the more chances they are to help you. If you go in there late notice, they're going to probably be a little bit more stressed out. So it's better to give them as much leeway as possible so that you can be set up for your own success. Next slide. So when we talk about testing, there's really 5 phases that we want to get into, and this is Steve again. It's test planning, where that's really probably where you're going to spend a lot of the bulk of the time in just the mind exercise. When we're talking about test strategy, you're talking about cost, you're talking about equipment, you're talking the best way to be efficient so that you can get the different planning done for each phase. Obviously, there's going to be more test planning going along as you go through each phase, but really test planning even in phase 1 is really important, because that's where you're getting the first results, where you're going to show your customers, so when they see what's happening, you get good results that can go into phase 2. As you move through this life cycle testing, you want to make sure in the analysis you get that you're solving the requirements you want to set up for yourself. You want to make sure you get the right test designs, the right scenarios, the right equipment, the right hardware. And we'll talk about all that a little bit more when you talk about elements of testing. But it's really important that you look at costs and cost savings and ways that you can get the information you need so that you can present it to the customer in a way that allows you to have the best success. Test execution is getting the tests, making sure the tests are done correctly, identifying the results, retesting, looking at defects, making sure that you are able to capture all the things you need in order to requalify or qualify your tests. And then in test closure, that's where you're going to make your reports and you're going to get them to your customer, and you're going to put your best leg forward in order to get the phase 2.
Great, I appreciate that background. Any other thoughts, Chris, Colin? No? Well, then we'll turn to Colin to take us through why we test.
So this is Chris. I'm gonna open up this slide, and then we're gonna give it to Colin. So what's important to realize about the testing for the SBIRs is that your primary objective is to retire the risk of the technology. Oh, sorry, next slide. Sorry. All right. So you're going to retire the risk of your technology. For an SBIR, your technology that you approach with your proposal is going to have inherent technological risk. Oftentimes, if you have too much proof that it'll work and it's too validated, they'll say there's other mechanisms to do it. So your technology is either the implementation in a new environment or a new technology in general. You need to retire the risk, and you need to validate that risk is retired to the reviewers. That's your primary goal. Also, the program manager, which Con will talk about, is incredibly important. So your tests are going to be used for that validation, and that's you want to be able to keep that in mind going from the beginning to the end, how you validate each component of the risk that was included in the development of technology, so that when it comes time to write your final report and subsequently your phase 2, say, proposal, that you have all of the ammo you need to say, yes, this is a thing. Each of these risk factors have been validated. But also, all 3 phases are, of course, going to require testing. We're going to go over kind of what that test load looks like for each of the phases in a future slide. And finally, you should plan on testing and evaluating all throughout, and you make sure you have those tests, because the worst thing you can do is test at the end and find out if you had just tested at the beginning this one part, you could have retired the risk earlier or known about a problem instead of backpedaling. So testing and making sure each component is tested individually is incredibly important. Colin.
Yeah, this is Colin. Just to emphasize one of the things Chris said was in the context of the SBIR phase 1 testing, it's to provide compliance and evidence that your proof of concept is doing what it says it does. The level of testing that you do in phase 1 versus the other 2 phases is, as an example, would be much less due to funding constraints, due to time constraints. So as an example, phase 1, you might not have independent testing. Phase 2, where you've got more funding, more time, you may be able to do that independent test and evaluation.
Any thoughts, Steve?
No, this is Steve. I think they covered that very well.
Great, now I'll turn it over to you, Steve, to take us to the next slide, categories of elements for testing.
Great, thanks. This is Steve. So when in a rocket, the science, because how we test the science is really the driver of how we decide if we're actually doing our proof of concept and making the proof of concept successful. But before that, we really have to, when you look at the science, determine the hardware and software that goes into that. Because when you pick hardware, it could be simulation, it could be physical hardware, it could be things you have to get to the lab to use because you don't have those components. The software is, how much software do you need to write? Do you need to write it from scratch? Do you have a past performance that you've done before with something else that gives you a lot of that software written already so that the IP that you're trying to design in the science is already there? So a lot of the considerations for science really fall into software and hardware and how much time you want to spend in that. Like Colin mentioned before, in phase 1, you're not going to have a lot of time for testing. So you want to find something that can do something off the shelf potentially. We do a lot of work with a company called National Instruments. National Instruments is COTS hardware that you can set up very quickly to do some testings around so that you can go and validate very quickly, write some LabVIEW code and make sure it's up and running. There are other ways that you can do things with Python and other hardware platforms now that allow that just as easily. But what you want to make sure is that are you testing things at the component level, the standalone level? Do you have to do integrated testing? Do you have to do system assisting testing? So all these things play a role in the type and amount of testing you have. And then once you really go into a phase 2 and a phase 3 and you need to go into government type labs, that's where you're going to get into developmental test and evaluation, where there's actually, when you bring your component or your system in, they want to validate it at the government lab to make sure it's working. That's where they do that. Then acceptance testing is that the government is actually allowed to accept it, and that they have accepted your product. And then finally, there's this operational test and evaluation. Does this actually work in the field? So all these things allow you to get set up so that you can have successful testing and know the right elements of your test and your test plan.
Great. Colin?
Yeah, this is Colin. I would just add, one of the things that came up was there's a lot of test equipment out there. There's a lot of third-party resources you can use. Some very, very lightweight, some more of a heavy cost component to it. So it's important to do that research up front. Make sure you're picking the right tools, the right experts, if you need it, for the testing, so that you're not picking something that's going to waste time or money for you.
Yeah, I'm going to agree with that. It's incredibly important to be realistic about what you can retire the risk of in the phase 1. The phase 1 is a very small pot of money. Just to give an example, so they're talking about off-the-shelf parts, things like proto boards, electronic chip proto boards are very popular right now. If you've ever developed a PC a PCB, they take weeks to get printed. You got to do component testing on each individual. I mean, that's a week, 2 weeks, a month of just looking at electronic circuits. You don't have that kind of time necessarily in a phase one if you can help it by getting something that's off the shelf. You got plenty of time in phase two to make your own custom PCB, to get all of those components tested. But phase one really comes down to validating, retiring the risk of the core of your concept. So any tools you can have that are off the shelf, and understanding, as Colin said, understanding those from the very beginning is incredibly important, because the program manager or the reviewers, when they look at what you're proposing, they're going to have that in mind, reality of what you're trying to accomplish in that time. I've gotten a few times where people have gone, you have too much scope here, you'll never get it done in this, it's impossible. So they are cognizant of what it takes to do this type of testing and evaluation.
Great, I'll turn it to Colin to take us through the test plan template. Next slide, please.
What we're really talking here is a test plan strategy as well as a test plan template. The strategy belongs in your proposal that you're sending forward, and it's critical that you have that. The test plan template, or test results, test steps, that'll be part of your deliverables to your government program. So with the test plan template itself, this is a written document. It's one of your most important documents. Most engineers don't like to document, me included, but I can't overemphasize how critical it is that you get a document that has the scope, objectives, and when I say objectives, I'm talking the plural. This is not just one objective that you have for having a successful test, as well as the equipment required to do the testing, the test steps, and the steps should be at a level where another person could run the test and you get the same results that the actual designer got from running the test. So in other words, it should be a very comprehensive document that gets delivered with your deliverables, and that an independent third party could run.
Great, any other thoughts?
Well, in the test requirements point of view, when you're doing the strategy, often there are different phases where you have to look at integration. You have to decide if you have pass-fail tests or if they're tolerance testing. There are different areas in your test plan you have to fill out to make sure that you know the results that you're trying to capture. So, and they happen at different times and at different parts of the SBIR phases. But that's something to think about, is what the result is you're trying to obtain.
Great, I'll turn to the next slide and continue on with Chris to take us through the test plan.
So this lays out some of the critical questions that need to be answered when you're creating this test, when you're filling this plan out. So the cycle, what the cycle is, that's kind of like, you know, what are your strategies for each individual test or component test. Accessing the test equipment, this was something we covered with the labs. In phase one, you're not going to have a lot of money to get in and do full lab testing, but there's plenty of resources out there, and the reviewers are going to want to see that. Partnerships with universities, partnerships with other labs, partnerships with maybe partner companies that you work with. These types of things, having the test equipment available and showing that you have those. And these are things like letters of support are going to be really important to show that you didn't just pull somebody out of nowhere, that you actually have these relationships and you can get the job done. What the strategy is, that's been talked about a lot, but making sure you have a cohesive strategy, you know what you're testing, how you're testing it. Something that is also important is you always submit who's going to be working on the project and who is going to be doing the tests, and then do they have the skills and the capability to run the tests that you're actually trying to achieve. That's incredibly important. They're going to look at that and make sure that the credentials line up with what the requirements are for the testing. So making sure that you have a team that can test in the case that you're doing the testing yourself. When you're doing the test design, if you've said you're going to test and you're going to test the last week of the project, it almost looks like you're assuming there's no reason to test at all. It's okay to actually plan in some level of fail or redesign into your test plan. In fact, it's almost encouraged. If you're too gung-ho about it, again, it looks like it's too validated. So you can actually have these types of steps to say, make sure you can recorrect, make sure you can go back and say, oh, well, I'm going to fork off this way now and try to solve this problem this way. And then what level of testing? These are system tests, acceptance tests, and just somebody else coming in and doing a third-party validation. Having all these, third-party validation, not necessarily for phase 1, but as you get to phase 2 and certainly phase 2B, other people are going to have to start using your equipment and doing independent testing of it. So having all of that in your template test plan is important.
That's great. Chris, we'll stay with you to take us through the SBIR phase of testing. Next slide, please.
Sure. So what this tries to do is kind of just highlight the importance of each of the 3 components of taking a technology from concept to commercialization. In a phase 1, you're going to focus mostly on development. Yes, you're going to have to test, but really you're developing the core concepts there. And you're validating those core concepts. Again, you're not making your custom PCBs unless you have to. You're really just saying this technology, the core of this technology, the proof of concept will work. Commercialization is in a distant future at this point. You don't really, other than starting to find out who's going to be interested in the technology, because for phase 2 you will have to show some commercial interest in it. You're not really commercializing the product in general. Phase 2 is where you're going to start doing a prototype. So now you're going to start getting some of these core supporting components to get the technology matured. So there'll be much more heavy testing in there because you've developed around a lot of the core concepts of your technology. Again, commercialization is, while important, your focus here is turning that concept into a prototype. And finally, phase 2B, now you can start to talk about how you're going to get it into the hands of either the warfighter or the military or whoever is your targeted end customer. You'll still be testing, but development should, for the most part, be done. Maybe you're adding features, maybe you're adding some quality of life capabilities, but in the most part, you're testing and you're commercializing.
Yeah, this is Colin. The commercialization, as you can see, shows up in all 3 of these phases. So even though you're building towards commercialization, mentioning it in your phase 1 proposal and having part of that as your plan, as your strategy, is very important to show upfront that you can get to a commercialized product.
Steve, anything to add?
I think when we're talking about the CRADAs, that really is showing up maybe in the phase 2B and in the phase 3 of these phases. So that's moving down even further in commercialization when you're actually wanting to integrate and show what that would be looking like at the product level. So I just wanted to make sure we understood that from when we get the lab involved or we need a CRADA, that's when we get to a phase 3 where we're going further and further along commercialization.
Really good point. I'll turn it to Colin to take us through key considerations. Next slide, please.
This is Colin. Many of the SBIRs that I've submitted have been to build products that are test products. I'm going to ignore that, the nuances involved with that for a minute, and talk about an example of a submission we did, which was an app to help parents identify concussions with their sons and daughters who are student athletes. In this particular project, there are different testing considerations that need to be considered. So you've got technology that requires testing from a functional standpoint initially in phase 1. You've got operator usability, once again, from a functional standpoint. And you've got HIPAA certification because it's a medical product that you need. So don't forget to consider certifications that you might need once you get to commercialization, even though you don't need it for the proof of concept necessarily. One of the areas with certification that's really time consuming and hard is working with standards bodies to figure out, to influence where the standards, where the certifications are going. It can be a huge amount of your time trying to do that. What I recommend is that use friends and colleagues who are on those standards bodies to run past them. What do you think the standard's going to be for X, Y, or Z? Right now, we're looking more at automotive certification. What's not only available right now, but what's going to be coming out soon that you should be aware of, and that's where you ought to be targeting, for the near future.
Steve, Chris.
Let's see, Chris, in your experiences, I think both you and Colin, you've had to get letter of agreements from different companies as you move forward in the process, whether that's equipment, whether that's people that want to use your solution. Can you speak a little bit to that, of where these letters come in and how people are setting themselves up so that they know what needs to be happening with their engagements and the different things around?
Sure. Yeah. So Xstrata is a small company, and so we don't have the infrastructure to support everything that would be required. And they realize that. I mean, they like to support small business, especially small tech firms. So that's not necessarily a problem. So the letters that we generally get come in probably two categories. One of our main ones is what we're talking about here, letters of support for test and equipment. So we've partnered with universities like the University of South Carolina. We've partnered with Arizona State University. We've also partnered with labs, Brookhaven National Lab for one product, and Argonne National Lab, where the labs were crucial in having access to equipment that we just simply can't have. Universities also have a lot of equipment. Professors are always interested in testing new and working with new technology because they see it helps give them ideas for new grant proposals and that kind of thing. So getting those letters of support is can be as easy as just calling a university. You see a paper if someone's doing something similar and calling them up. They'll at least want to talk to you. The other kind of letter we usually get are letters of support about what Colin's talking about, which is that there's validation that somebody in industry cares about what you're making, either to the point where they are saying, if this works and this, we can act as a distributor and we can help support, commercialization of this, some kind of level of interest from a industrial entity that can help convince the reviewers that, yeah, okay, there is somebody out there that cares about this other than, say, the DoD.
This is Colin again. Universities are great. Grad students are inexpensive, they're smart, and they're trainable. So if you're looking to outsource, going to universities have been a big cost savings for us, as well as it looks good on your application. Having that mix that Chris is talking about between the outside industries and the universities, that's a winning ticket.
Great, we'll stay here. And next slide, please. We'll keep going on key considerations with Colin.
So testing is a team sport. And I want to focus in on how geography plays into this. As an example, we were a sub on a SBIR. We're in Maryland, DC area. The prime, the principal investigator, was in North Carolina. We were doing RF cybersecurity testing for the prime for their device under test. Because of not being face-to-face for initially, we wasted a lot of time shipping equipment back and forth because we couldn't afford each of us to have our own test setups. It was also, the collaboration was much less effective. So what we ended up doing was really training the principal investigators, grad students, got them set up so that the collaboration could be done in real time. And we were able to step back and do what we could do remotely from there. So the point of the geography usually, well, can matter with testing. If you are fortunate enough to win a phase one, you know, the objective, obviously, the main objective is to get to a phase two. So being judicious, smart about how you're outsourcing, whether you've got people that are co-located or remote, just make sure in your testing that you are distributing that in an appropriate manner.
Any other thoughts?
This is Steve. Probably one of the most important stakeholders is your government contract. I think Colin will discuss that a little bit. And making sure as you go through all this, once you've won, that you're keeping close to that person so they can help you move through this process with them. And they will be able to guide you and give you answers and give you ways to get letters or ideas. And they're just really a very good advocate for you. And so also when you're doing your ROM and you're going back to some of the things on the ROM and pricing this, you want to make sure that you have the things in your test plans and in your quotes to make sure that you're realistic. We have done things more from a testing standpoint from DT&E and OT&E where they're more expensive. Chris and Colin have done more at the SBIR level, and so maybe they can talk a little bit about building the ROM from your SBIR.
So this is Colin. The cost proposal that you use needs to be as detailed and exact, at least from an internal use, as you can possibly make it. What gets sent out, usually you can make it more generic, give yourself more leeway so that you're not in a position where you're caught short. But once again, you do have a finite amount of funds, so you've got.
Yeah, no, I agree with everything that they've said. I mean, you have some flexibility once everything. I mean, they understand that things happen, right? Things come up, and no one's unreasonable. Again, they expect these risks, so they don't expect everything to go exactly as your Gantt chart. So that's okay, but it again has to look reasonable based on everything that that you've considered those. So talking about, I'm sorry, go ahead, Colin.
Yeah, this is Colin. If you're testing in a way where you're not finding failures in your product, you're not doing a good job of testing. So to the point Chris and Steve were making, you do need to test early and often, make those changes in the design if you can afford to do it. You can go through a phase one, show where the failures were, and incorporate that into what you're going to do in phase two.
So yeah, I'm just going to bring up for us, this can be pretty tricky. We've had a lot of experience with this. We've actually, so I have two sides. So we've won quite a bit of phase ones, capitalized on phase twos, but we've also lost phase ones. One of the most recent examples was a water monitoring system we had made, and we simply couldn't afford, based on the phase one cost structure, we could not reasonably include in-field testing. And one of the main reasons we didn't get the phase two, and one of the feedbacks we got was that, oh, well, you didn't test in the field. Even though we specified in phase one, we don't have enough money to do this. So it can be quite challenging to, and it really depends on who's going to read it and what they think you should have been able to do. And what you saw there is an example of phase one going, yeah, I get it, you don't have enough, but phase two going, yeah, but you really should have done this. And so it can be very challenging to satisfy all of the risk in a phase one, especially depending on the novelty of the technology, how much you did have to build from the ground up. This is something that we haven't talked about yet. I don't know if we're going to talk about it again, but one of the key things about even considering an SBIR is grounding it in some technology or something that you already have available, building off of a platform, building off of something. There's got to be enough building something just from a concept. And I see some questions we'll get to later about this. Building something straight from just a concept with nothing and no historical technology development, it's going to be challenging. This was an example of we really built this on the ground up. We even had the technological capability, we just didn't have the funds to do it. So I think, and I'm sure I'll come up with some other examples, but that's the one that sticks out in my mind the most as far as trying to get this balance of what you can validate versus the cost of covering it.
This is Colin, and a lot of that goes back to your testing strategy that you write, that you get verbalized in your upfront proposal, so that there's an expectation with the approvers that this is what you're trying to validate testing wise, and the scope of that doesn't expand on you too much as you're actually working a phase one or a phase two.
No, this is a really good conversation. I look forward to continuing this in our discussion, but first we'd love to turn to Steve to talk about lessons learned before we get there. Next slide, please.
So we've talked, this is Steve, we've touched a lot on this already. We talked about, Chris just talking about reverse engineering some some failures and success, and we talked a little about that. And we talked about that it's really important that you have something out there that has existing IP. And our rule of thumb is somewhere in the 50 to 60%, that we have something, 50 to 60% of existing IP that allows us to move quickly through an SBIR phase one to show them that we have something. We don't have to do a lot of work in the phase one to get to a phase two. Obviously, there's situations like Chris has talked about that if you don't have the right amount of testing, or if somebody's reading it in a way that they're looking for something you didn't have, you could be at risk of that. But that goes into how you retire the risk and goes into cost. And really, as we talked throughout this whole conversation, it's never too early to start testing. If you start testing as soon as you get a phase one and you start looking at your problems, and you can do redesign, revalidation, and requalify all the way through, you're going to be further along and be down the road quicker. And so again, to go to how far do you need to look at risk in phase one, you don't have to be very far down the road to retire risk. And as we talked earlier, there's getting these letters of support for testing and for validation, and people that want in the field. These are all very important lessons learned. And I'll turn it over to my colleagues for any stories they may have.
Yeah, this is Colin. So zeroing in on how far you need to go in phase one to reduce risk, you really need to be in sync with your your government representative, you need to be with your program manager on this, so that, once again, the expectation is what it needs to be. And any of those redirections, course directions you can do during the project itself, that you can afford to do, you've got that information so that it can lead to a successful approval for phase 2.
This is Chris. I'm going to just touch quick. We'll talk about it more, but on the 60%, I was just going to clarify that. In our view, at AccuStrata, we have these core competencies of optical metrology on optical spectra, remote sensing of those, and machine learning. So when we are looking for SBIRs, potential new technologies, potential places that we can start to innovate, our focus is utilizing those 3 core concepts in can we solve this problem that DoD has in this case. So if they're trying to do something like create a new canopy material, we're not going to do that. We can't. There's nothing we can do in ceramics. There's nothing we can do in metallurgy. So we focus on our core technology, and we can break that. We can push those, be innovative on the machine, heavy on the machine learning, for example, or heavy on the remote sensing or the process monitoring. But in the end, what I think now is if you go and just look at everything that's cool out there, there's you can look and you say, oh, I would love to work on that, but you need to have some platform that gets you through that phase 1. Otherwise, it's a lot of time to write these. It's a lot of time. It's a lot of revisions. It's a lot of lit searches. It is not easy, and if you go at it with a lot of risk, you're going to waste a lot of time on writing and not getting any capitalization on it. So it's really important that you base it and ground it in some core technology that you have.
This is Colin. One of the other things you want to make sure you're doing in your phase 1 proposal is to show that you have the background in this industry, that you understand the certifications that are needed, even though you may not need them, or you probably won't need them in phase 1. So at a high level, without using up a lot of your critical page space in the proposal, phase 1 proposal, mentioning what you're going to do further in the process is very important. Shows that you know the industry, you can take it not just from a technical standpoint, but you can take it as an entrepreneur, as a small business owner. You can take it all the way through and successfully get it into the commercial market.
Okay, that was just a great vast amount of information that you shared to this point. What we're going to do today is a little bit different than what we typically do. We do have some questions that we're going to field, but we're also going to just open it up to the panel and just have some good discussion about some key topics. I think that the audience is most interested in areas where you did fail, where you learned from failure, and how you kind of turned that into success. As a reminder to participants, we will send a transcript of this webinar via email within 30 business days, as well as posted on our SBIRS Sitter, that's SBIR STTR training and advocacy website. I'd also like to remind everyone that if you have a question, please click on the blue button, the blue question mark located at the top of the page. And also, for each of the panelists, just remember to state your name before you respond to any questions.
Great. So I want to get started and pick up, dive back a little bit to where we talked about the test plan. What came up there were a couple things I want to dive into. One was the idea of creating test objectives. And so would love to chat more about what are examples of test objectives, how does one design good test objectives, and how does one align those test objectives with the government, who is the ultimate customer here?
Yeah, this is Colin. A couple of things in that area. You want to make sure you have good, strong requirements. So you should be testing back to your requirements. There should be direct mapping there. The other aspect of that is that
this is Chris. Yeah, no, and I'm going to, no, that's right. I'm going to agree with that. When we go through so when we get a phase one or we land a phase two, we're always making sure that the critical thing is that you deliver on those milestones and objectives, right? I mean, you have a lot of fluidity in the write-up, in the work plan, and the tasks. There's a lot of hedging on a lot of that. But the core of what that delivery, that's what they're going to expect is you have this deliverable or you have these objectives, and that by the end, when you wrote up your final report, that those were retired. And so when you talk about what kind of testing you do, all of it comes back to making sure that you made a convincing argument that risk is retired, that you have enough information that this core concept, proof of concept, is going to work.
This is Colin. Just to add on the objectives, the commercialization end of who the actual operators of the apps are has been very eye-opening for us. When we did the app for the concussion, one of the things we stumbled over was we had people running the app who were not the designers, and that wasn't on purpose. We just kind of did it, and we saw how much operator error was injected into the interface we had. So it allowed us fairly quickly to go back, put in coding, an interface that didn't allow the unreliable data to get put into the system. So having an operator testing part of this is important if indeed your in commercialization requires operators who, in this case, were mothers and fathers, just wide segment of the population, versus someone who would get specialized training on a piece of gear that would potentially go into the warfighter. So looking at who's going to be using it on the commercial end, bringing that all the way back to your objectives is important as well.
Yeah, this is Chris. So I have an example. Right now we're currently in the first year of a phase 2B on a monitoring system it's an atomic absorption system, but it started as a phase 1, moved to a phase 2, and now we're in the phase 2B. And so for the phase 1, our main objectives were just have a monitoring system, and we had a lot of design decisions that ended up halfway through being totally outside of physics. Like the whole concept didn't work. Luckily for that phase 1, we were able to correct, and we worded our milestones in such a way that it didn't matter that the detail of that design decision had totally changed, because in the end we were able to find a new method of operation that allowed for a successful demonstration of the deliverable. So that was an example where we actually did it correctly. Our deliverables were specific enough about what we were trying to achieve without what it was that we were doing, that we were able to recover, and we tested early enough that we were able to find out that was not the original concept was just not a solution moving forward. So when we moved to the phase 2, it was definitely, the objectives were more on the proof of concept. That's when we went to the labs. So that's when we had our partnerships with Brookhaven and Argonne. We actually took that core concept that we had partnered with University of South Carolina with. So again, this is kind of coming from the experience of the first phase 1, we couldn't afford the labs. The labs moved really slow, but the universities have those grad students Colin was talking about, and they love working on this stuff because it gets them a paper, it gets them a thesis, it gets them out of grad school. So it's true. I mean, and I've been there, so I would have done the same thing. We able to capitalize off of that partnership, and they support their grad student with that too. I mean, you're allowed to have subs on these. You're allowed to fund and have partners to work with. They expect it and sometimes encourage it. By the time we got to phase 2, we were able to partner with Oregon and Brookhaven, bigger, like you said, slower, kind of harder beasts to work with, but with a 2-year phase 2, you have that flexibility to work with them. Finally, right now, we're in the phase 2B where our phase 2B is primary market verticals and finding commercial partnerships and working on new sort of application verticals for the technology. So I just wanted to lay that out since we're talking about objectives, how it's crucial to get those right. And sometimes it's a trial and error thing, but also don't be afraid to resubmit. Read the reviews. You put a lot of work into these things. You got it far enough to think you had a good idea. And so read the reviews that come back. And, we've actually written a phase 1, totally failed flat on our face, took the same core technology and put it into another application, and we won the phase 1. So it's good. You're not wasting your time from the perspective of, as long as you believe in it, you think it's there, keep on pushing. Someone's going to think if there's a use case for it.
So along those same lines, I mean, on the federal side, in the government as a customer, who's their decision maker? How do they evaluate testing from their side? Is that the same person that's the PM, or is that another group entirely?
This is Chris. They're reviewed. My understanding is they're reviewed in the same way as they get a panel of experts, whether university or maybe a lab scientist. So the PM is not the end all be all. They don't just look at it. I mean, it's vetted by a group of experts in the field. So you get a chance. You get, I think, 3 reviews, but it comes down to the PM as the core decider. Because what they'll do is they'll get all of these positive reviews back, and they can only accept 10, 20% of the positive reviews, something like that. So in the end, he or she's going to be the one that cuts them, the program manager. So you want to be friends with the program manager, but also be realistic enough that you're going to get through that vetting phase. It's also important to note that your phase 2 proposal, at least for some SBIRs, I'm not sure about DoDs, but for some programs, they actually have 2 reviews. The technical review, that's reviewed by this panel of expert scientists, but you also have a commercialization review. That's done more on the financial business perspective, so it's someone totally different that says, yeah, I can see this growing into a product. And they're weighted differently, but so you gotta know both sides of it. You gotta know the business side and the science side.
Got it. Steve, Colin, any thoughts on that?
Well, this is Steve. One of the conversations Chris and I have a lot of is, do we go do an SBIR because it's a very small market, even though it's targeted? And then we know there's a need, but the need may not be more than 1 or more than 10. And Chris and I have actually worked on a couple of projects together where we've done things outside the SBIR and created a couple of products. One was a pherometer that we thought there was a market, and it sounded like it was a good idea that there was a market, but we're still looking for the market.
Somewhere.
And the other one is actually something that has a market that's a fairly big market, but growing market now, that AccuStrata has put together for an industry. So what we talk about all the time is it better to use the SBIR for something that's targeted that might have a limited scope, even though the scope may grow? Or is it better to find something that's more commercial, that allows us to have a market, but we have to figure out how to get to the market? And so, Chris, if you could just chime in a little bit on those 2 examples that we did on.
Sure. Yeah. So this is Chris. So from that experience of doing commercialization, both from just a traditional, you have a market and you develop it. When deciding to do an SBIR, in my mind, the nice thing about SBIRs is they tolerate a lot of risk. You can come in with, as long as you have some notion and some backing on a literature or something that this is a concept that'll work, you have a chance for a phase 1. Getting funding to do research on we'll call it a harebrained idea in industry can be much more difficult with a lot more financial risk than an SBIR, where if you don't get through the phase one so well, you still, they understand. But the counter to that, which Steve was talking about, is that what the DoD is looking for, what some of these other labs these other calls are looking for, tend to be very nuanced, very specialized. If there was a market for it bigger than that one application in DoD, for example, generally someone would have made it already, and they would be selling it all over the place. A lot of times they're niche concepts, niche industries, and it can be incredibly challenging to find a real commercial market for some of the calls. We've actually had some calls where we decided not to chase it specifically because we couldn't find a commercial market outside of that one Air Force lab that we could utilize it for. So, Steve, is that kind of what you're thinking? Yeah.
Brings up a really good point. With most of my background's been with DoD. Most of the SBIRs I've submitted have been with DoD. But finding that sweet spot of DoD application and commercialization might not always be there. They're not the only department in town. Going to NSF or any of the other agencies and departments is a good idea. So that you're not, like Chris is saying, he's got a technology, it might not fit in with one particular agency, but it may fit in perfectly from what that agency needs, as well as getting it commercialized for that particular application.
No, that's great. And you all actually got hinted at the idea that if you're more established, I call it a more established SBIR firm, you have past performance. But I would love to get your perspective on how impactful is past performance on these programs. And if you don't have it because you're new or you're just getting started or you haven't been successful winning, how do you augment your team so that you can kind of fill those gaps?
So this is Steve. When you have gaps, you always have to figure out how to fill them, like you suggest, whether it's teammates. So when you're small, I'll just start with, your teammates really are your bench. And one of the reasons the three of us are in this room right now together is that we're all teammates. And we all do different things for each other. So we're doing work right now in NIH where AccuStrat is subbing to us, doing deep learning stuff and looking at microphones, microscopes, sorry. And Colin, we're working on some stuff where we're building cyber physical test benches. So as a small company, and the way that ADS has been in business for 21 years is through the partnerships. If we didn't have great partners, if we didn't have people that knew how to get things done when we had gaps, we would not make our customers as successful as they are. So I don't think it matters in an SBIR so much if you're new or old. I think it matters what your team looks like, who you're bringing to the party, and how the party gets started. So it's really important that when you look at this, whether it's your test plan, whether it's your objectives, whatever you're looking for to make sure it's the viable solution, that you're looking internally and at your partners and anybody that can help you from a lab standpoint, that you are putting your best face forward for success.
This is Colin. Just to be clear, past performance isn't necessarily SBIR past performance. It's what your company has done, as Steve's mentioned, what your partner companies have done. So don't ignore your company's past performance and the individuals that are part of your company that are partners with your company as well.
Colin, anything? Great. So we've gotten a lot of questions about costs, and we've touched on this some throughout our piece. I think there's a lot of folks who understand that phase one is tight. And so they're trying to find ways to reduce those costs. We talk about letter support, universities, labs. Are there other ideas out there that the group might be able to recommend? And then would love to get some sense of, is there, I hate to say rule of thumb, is there a rule of thumb or a segment of what portion of your funding should go toward testing or could go toward testing reasonably?
Yeah, this is Colin. It does depend on your product. A lot of the products we submit are testing products themselves. So those are going to be skewed very heavily towards testing, whether it's validation of the tool or validating the results that your tool is coming out with. So in that case, you may be up to 50% of what you're allocating. For other products, could be much lower. And I don't know what the experience has been with.
Yeah, this is Chris. Yeah, no, I actually even with ours now, we're also a lot of ours. So we do optical monitoring, and so a lot of ours is also not the monitoring equipment, we'll call it. A lot of our technologies require big semiconductor systems, semiconductor fabs, and so we have to get into either a university or a commercial partner to test, and so that costs money. It costs money for them to run the equipment, which is not cheap, the materials to use, and validation of the technology in a phase one is the most critical part. I mean, you have to have the technology developed, but you're going to spend all that time. I mean, phase one's not a lot of money. You're really trying to shoot for that phase two. So you're trying to do the exact amount of work required to get to the phase two. And so you're only validating what will get you. And it's that's kind of where it becomes an art, right? I mean, because you can say, oh, I only think this is important. And then I had an example where the reviewer goes, nah, it was more important that you did this. We're like, oh, we could have done that if we, if that was the most important part. But so it is a trial and error. Does depend on who gets there. But if you follow the rule of thumb of retire the risk of the core risk, look at your technology, look at what you're trying to do, find where your greatest weakness, your great fail modes are. There's a reason you can look at it this way, and this is how I look at it. There's a reason I'm not just going out there taking my money from the company and trying to build this thing. And what is that reason? Where is that risk point? Why am I not just doing this right now? And we've written a phase one that actually had exactly that. We wrote a phase one where we were like, this is a slam dunk. It's perfect. I mean, look, there's all this literature. We're experts on this. The reviews came back and they go, yeah, all right, go do it. Like, what do you need us for? And we're like, oh, all right. Well, so that was a good lesson. Like, okay, well, it's got to still have some risk to it. I mean, otherwise, go make it. Don't bother us with things that you already know will work.
Yeah, this is Colin. It seems weird for guys who do testing to say, hey, do as minimal amount you can in phase one.
Yeah, that's right.
But that is the message. Do what you need to do to get to phase two, where you've got more funds, where you can do the proper testing before it goes to commercialization.
Remember that phase one is really still just a proof of concept. Just giving enough to make sure that it shows that it works and it's viable. Phase two is more of your prototype. So that's where you're going to go and breadboard it out, do more stuff, test it more rigorously. And there's a big jump. Typically, a phase one is about 75K.
Up to 150.
150, and a phase two can go up to
a million for 2 years, 1.5 sometimes.
So when you look at just the pure funding and cost that's available based on phase one and phase two, you can only do so much testing, and this is Steve, for your first phase or your first $150,000. And if you can show a good proof of concept and you can get to a prototype phase, then they're going to give you 2 years potentially at double or 3 times the cost to be able to build out your prototype.
This is Chris. There is one thing we did learn to help with costs, so I'll bring this up. A lot of companies that have test equipment have demo systems, and you're going to need, and you can go to these companies, these big companies, and say, hey, I'm on a phase one, which oftentimes, big is in quotes, but a lot of times they're familiar with SBIRs. They understand the program. They also understand that if you get a phase two, you're probably going to need that equipment. So if you can use that equipment and validate in phase one, you're probably going to buy it in phase two. And if they got it sitting on the shelf, we've done that for the past 3 SBIR phase ones. We've gotten some level of demo support, either iterating over a component, saying, hey, can we borrow this one? No, that didn't work. Can we borrow this one? And then finally buying the last one, or a testing equipment that says, I need to test this just to get it, I'm minimizing the amount of time I need it. I only need it for a month for this particular test, but we're going to need it way more once the phase 2 comes out. So can we try your system out? And if they lend it to you, you're probably going to get theirs over somebody else, other competitors anyway. So it's kind of a win-win, and you get access to that equipment depending on what it is. So always consider that. It never hurts to ask if you can borrow a system.
Yeah, this is Colin. Steve had mentioned building on other people's equipment. He had mentioned NI, but there's other test equipment out there, platforms out there. So building on somebody else's equipment, using that as Chris is suggesting, hey, yeah, we're not making money on this now, but if we get this commercialized, you now have a stake in this. Your product, your platform could be part of our marketing sales strategy once we get this commercialized.
And this is Steve. Just to piggyback on all that, when you talk about how do you reduce the cost of test? Because in all of this, you want to reduce the cost of test. You want to basically, if you can, as Chris has suggested, find demos, as Colin suggested, find companies that are doing this already. Leverage everything's out there. Don't ever think you have to build it yourself. So many things are out there, whether it's software using free libraries, whether there's so many ways to do things for next to nothing, that really thinking about all the ways to, even with hardware, how to simulate the hardware, how to do things where you don't need hardware at all. So always thinking about what the means to free is, or what the means to reducing that cost as low as possible. Make sure you're looking at all the different ways to do that and means to do that. If you have to go buy something, make sure it's a product that you can reuse in different ways. There's lots of products out there that you can use as a oscilloscope and a voltmeter and a spectrum analyzer, or all different ways you can configure a test. And so think about ways of reusing your hardware over several different SBIRs that gives you the best way to minimize your cost of test.
This is Lynn. I have a question. You make a great point about making sure you have these partnerships and looking for people. Where do you go and find some of these companies? Like, what's your method for getting yourself out there, meeting new people that could potentially be partners? So how, as small companies, super companies, how have you done this in the past?
This is Colin. One of the most effective things we've been able to do is speak at various engagements. We specialize in cybersecurity. So looking at that market, not everyone is looking at test. So going and speaking about test to a group of people who aren't in the test and validation business has been a good strategy for us. It kind of draws people right to you. The other thing, we've been involved in a limited number of NIST standards creation, as well as one with CTIA for Internet of Things devices, and that also gets you in the mix with networking with people that you can take advantage of them being much bigger companies than you are. So those have been the two things that I've focused on.
And this is Steve. Certainly to piggyback on Colin, networking is certainly a very big, important part of how to get your name out there, how to find partners. We all know each other through our networks, and we all know each other through several years of knowing each other's principles and just being out there together and working on things together. So it's really important that as a small company, you're in consortiums, you have places to go where you can network, and you're out there. It's a full-time job, another full-time job to be out there networking.
This is Chris. I agree with everything, and I just add. I mean, I've also been in the situation where I've mentioned this before. I've looked at universities who were doing research that was related to that could capitalize on the technology, and I'll call the professor up directly and speak with them, or a lab scientist at one of the national labs, and talk to them. A lot of times, if you have some interesting ideas, there are a lot of times scientists, people who are interested in ideas, people who are interested in new tools to incorporate into their labs. So it's not as daunting. I think I don't think you get a lot of negative feedback. Maybe there's no synergy, but I don't think you could call somebody and have a bad discussion. That doesn't, at least it's never happened to me. I'm sure there's someone out there, but.
Yeah, this is Colin. That's an excellent point about the universities. They are such an important resource for us to tap and for you to tap.
I wish that we had so much longer today to talk about some Q&A. I think at this point it would be nice to have just kind of a summary. Just think of maybe 3, 4 like kind of best practices, just in summary for the audience from each of the presenters today.
This is Steve. So in summary, I think the points of interest I think that are important takeaways are: 1, think about testing the whole time from when you first read the solicitation. How are you going to test? Because if you can be thinking about testing, a lot of times we don't think about testing. I mean, if you look at most of the world today, whether it's cell phones or anything else, these big companies are using us, the population, as the beta testers. Because technology moves so fast that the companies don't know what really works and what features work. And so they're always hoping that we call in with the problems, they can aggregate them and figure out where to go and attack. So testing is always a matter of dollars and risk, and how do you balance those two? I think the second is, how do you reduce your cost of test? Whether it's finding demo equipment, whether it's finding free software, whether it's finding partners that have things, university, leveraging. So certainly understanding how to leverage all the technology and technology partners you have out there reduces your cost of test. And the third thing I think is just for us is the lessons learned. How do we look at our core technology and say this fits or doesn't fit, or I have a good chance of a win, or this gives me an ability to be competitive, so that we think we're putting in a good grant or good application for the SBIR.
This is Colin. Yes, Steve, that's a great list. The only other thing I would add is testing scope, testing objectives. Know it up front, follow through with it. That doesn't mean it can't be course directed, redirected. It doesn't mean you can't change. It just means be very judicious when you do that. Have a reason for changing the scope, the objectives. Make sure you can afford to do it.
This is Chris. Yeah, and so the bottom line take home for me is when you look at trying to figure out what tests need to do. First of all, experience is huge. That's why you're all listening to us, because experience and knowing what works and what doesn't is hugely critical in the SBIRs. And looking critically at find those pieces of the technology that are the highest risk, and even to the point of choose the most, the highest risk, number of highest risk factors that you can afford to retire, and retire those, because that's what's going to get you your shot for the phase 2, where you can work out all the real bugs of the technology you're trying to develop.
This is Colin again. One of the things I think we should emphasize is finding failures in your products through testing. That's success. Not finding failures.
You probably didn't look hard enough.
I've had many instances where someone's shown me their test results and everything passed. That's when I start looking closer at how they tested, because that shows me they didn't do their due diligence on it.
That's actually a great question one of the participants had. How do you ensure that you've gone through all of the appropriate steps for testing? So how do you know if you've missed something?
Yeah, well, this is Chris. Yeah, you're going to miss something. No, you're going to miss something. The point, look, I mean, they're not unreasonable. Colin's point of, if they look at the final report and everything went so smoothly and everything was perfect, and that's, like he said, that's when they start looking. They're expecting problems. They're expecting shortcomings. They want to know where the problems came and how you solved them, because that's what a reality is. You don't have enough. The truth is, and they know this, you don't have enough money to get all of the bugs out. The whole point is making sure that the technology has some breadth of realism in, like, that it can do something. That's really what you have to focus on. But yeah, there's going to be something that missed. And in the end, you just got to convince that review board. I mean, that's who you're trying to convince to move you over to a phase 2. So you got to picture what they're going to want to see. Not fabricating data or anything, but they want to see that you're, I'm not condoning any.
Okay. Any final words from anybody? Any of the panelists, presenters? I think you've shared some great lessons learned, and just in terms of how to, the phases of testing, key considerations, lessons learned. We really appreciate that. We had an opportunity to have some SBIR companies, small companies that actually live this, and we hope that you've appreciated what they've been able to share with you today. Next slide. So I want to thank everyone for taking the time to participate today. As you know, this workshop is part of an ongoing series we're hosting about the SBIR STTR program. Our next and final workshop will be on October 30th. It's the phase 3 process, how to identify non-SBIR funding. So to register for the upcoming workshop, please follow the URL provided on this slide. Next slide. Previous workshop slides, audio recordings, and transcripts can be found at, and the address is https://training.defensebusiness.org/recordings/. We appreciate your feedback by completing the survey at the end of the session. Contact us at sbrtraining@bytecube.com. We thank you again for your attendance. We encourage you to join us for the final workshop. And again, just a great round of applause and appreciation to Steve, Colin, and Chris for sharing their insight on test and evaluation. We thank you all. Have a great day.